So, quick note on where we were. Last video, we did all the hard work of connecting. DNS found the address, TCP opened a pipe, so bytes can actually move across. And TLS wrapped it in that padlock. So, right now, we have a private, trusted tunnel to the server. So, the page just shows up now, right? That was the whole point. That is what I used to assume. But no. Here is the thing. The tunnel is open, but the server still has no idea what you want. You have not actually asked for anything yet. Think of it like a phone call. The line is connected, it is secure. Nobody can listen in. But you still have not said a single word. Connecting was step 1. Now you have to actually talk. And that talking, the ask, and the answer that comes back, that is HTTP. That is the whole video. And when I first saw what the ask actually looks like on the inside, it caught me off guard a little. Because at high level, it is just text. A few lines of plain readable text that you could pretty much type out by hand. Let me show you. This small block of text is this entire request. That's it. And it is really just a tiny contract. It says, what action do I want? Which thing do I want it done to? And then a bunch of instructions around that. And the server sends back its own little block, a verdict, and the result. That is the entire conversation. So let us open this up line by line. And by the end, loading a page is going to look like a very different thing. Because one page is not one of these, it is dozens of them. Okay, here is the request again. Let us go line by line because every piece is doing a specific job and none of it is random. The very first line is the important one. We call it the request line and it has three parts. First, get. This is the method. Think of the method as the verb of the request. It says what kind of action you want. Get just means I want to read something. Give it to me. We are going to come back to this word because it matters way more than it looks. Then slash orders slash 123. That is the path. It just names which thing on the server you are asking about. Here order number 123. If the server is a big filing cabinet, the path is which drawer, which folder. And sometimes there is a little bit after a question mark. Here, view equals summary. That is the query string. Just extra option tagged on. So the full ask so far is read order 123 and show me the summary view. Simple. Now the next line. Host shop.example. And this one is really easy to skim past. But it is holding something real. Because here is a fact people rarely stop to think about. One single server at one single address very often hosts hundreds of different websites. So when your request lands, the machine does not automatically know which of its sites you are here for. The host line tells it. DNS gave us the address of the building. Host says which shop inside the building. It is so important that a modern request is basically invalid without it. And then there are a few more of these name colon value lines. We call them headers. They are just metadata, extra instructions wrapped around the request. Accept, telling the server what format I can handle. Cookie, which might quietly say who I am. We are going to spend a whole section on this because this is where a lot of the real action hides. And there is a blank line, and that blank line just marks OK. The instructions are done. And after it, sometimes comes a body, the actual data you are sending along. For a simple read like this get, there is usually no body. You are just asking to read. You have nothing to hand over. But for something like a login or a checkout, the body is where the payload goes. We will see one. So that is the whole shape. A method, the verb, a path, the thing, some headers, the instructions, and maybe a body, the payload. And here is the one correction I want to plant right now because it changes how you see all of this. The server does not just receive a URL, it receives a request. The URL you typed got split up. The path and query went into that request line. The site name went into the host and the little bit after a hash, The fragment, that one never even leaves your browser. The URL is where it starts, the request is what actually goes. Okay, back to the first little word, the method. It is called the verb. Let me show you why that is the right way to think about it. Let us take one single thing, say item 7 in your shopping cart. One fixed path, slash cart slash item slash 7. Now watch what happens when I change the method in front of it. Nothing else. Get slash cart slash item slash 7. That reads it, show me item 7. Put slash cart slash item slash 7. That replaces it, make item 7 exactly this now. The same way for delete, that removes it. And post usually goes to the whole collection. Slash cart slash items. Here, add a new item. Same thing, same address. Four completely different operations. The only thing that changed was the verb in front. And here is where beginners get tricked a little because a lot of tutorials explain get versus post as get is for small data, post is for big data, or get is visible, post is hidden. And honestly, that is not really it. The real difference is about meaning, about what the method promises. Get is what we call safe, and safe has a meaning here. It just means you are only reading. You are not asking the server to change anything. Post is not safe. A post asks the server to do something with what you send, create an order, submit a payment. And there is one more word. Get is idempotent. Big word, simple idea. Doing it once or doing it 10 times has the same effect. Because reading does not change anything. Post is not idempotent. Do it twice and you might create two orders. And this is not just theory, it is why your browser behaves the way it does. Think about it. Because a get is safe and idempotent, your browser happily refetches it, preloads it, caches it. No harm in reading twice. But a post, this is why. When you hit refresh right after paying, the browser pops up that are you sure you want to resubmit this form? Warning. It is not being annoying. It knows resending that post might charge you again. So it stops and asks, the method told it that. So the method is the verb. Same thing, different verb, and the whole meaning changes. It was never about how much data you are sending. It is about what the server is allowed to assume you are doing. Alright, the headers. Those name, colon, value lines. And this is the part I want to land. Because when I was starting out, I completely wrote these off, like boring extra labels the browser tags on. They are not. The headers are basically the control panel of the whole request. Let me just walk you through a handful and what each one actually drives. We already met host. That one picks which site. So picture it as the router. It decides where inside the server the request even goes. Then accept. This is just the browser saying here are the formats I can take so the server can match it. Quick one. But the header I really want you to walk away with is content type. This one writes along with any body, the one you send up to the server or the one that comes back down to you. And it tells whoever receives it how to read those bytes. Because here is the thing, a body is just a blob of bytes. The exact same bytes could be a plain text, could be JSON, and JSON is just a simple text format for structured data. We will see it in a bit, or it could be an image. Content type is the label that says which one. So, application JSON, okay, run the JSON parser on it. Text HTML, that is a web page, hand it to the HTML parser. Image PNG, that is a picture, decode it. And if that label is wrong, let us say the body is JSON but it is labeled as plain text, the receiver reaches for the wrong tool and the whole thing just breaks. The label matters as much as a package inside. And there are more that we will really dig into in their own videos. But just so you see the range, cache control decides whether we even need to fetch this again or can reuse an old copy. Cookie carries who you are. Authorization carries your credential like a token, a kind of a key. Every single one of these is a lever that changes what happens next. So, that idea that headers are just optional metadata, let us kill it right here. Which site you reach, what format you get back, how your data is parsed, whether you are logged in, whether it even comes from a cache, all of that lives in the headers. So remember it this way: the method and path tell the server what you are asking for. The headers are where all those boring looking lines quietly turn into real system behavior. That is the whole point of this part. Okay, I mentioned that cookie header. Let me pull on that thread because it answers a question you have probably used 1,000 times but never actually asked. You log into a website, you click to the next page, you are still logged in. Feels completely obvious, right? But how? Because here is a strange fact about HTTP: it has no memory, none at all. Every single request is treated like a total stranger. The server answers your request, and then, as far as HTTP is concerned, it completely forgets you. The next request you send, brand new stranger. No idea you were just here a second ago. There is a word for this. We say HTTP is stateless. It does not carry any memory from one request to the next. So, if the server forgets you, the instant it replies, "How are you still logged in?" on the next page, something has to carry that "it's me" across each separate request. And that something is the cookie. And here is how it works, and it is nicer than you would think. When you log in, the server sends back a special header, set cookie, which is basically a little note. Here, hold on to this. Your browser quietly tucks it away. And then, this is the key part. On every request after that, to that same site, the browser automatically attaches that note back in the cookie header, so the server itself stays stateless. It does not remember you, but you keep handing it the note. It reads the note, looks you up, user 42, and personalizes the page. The memory does not live in the protocol, it lives in that little note getting carried back and forth. And you might be thinking, that sounds like extra work. Why not just have the server remember everyone? And this is a clever little decision because you carry your identity with you in that note. On every request, a server does not have to meet you before to help you. It reads the note and looks up who you are. And that is a big part of what lets a company spread its traffic across 1,000 servers instead of leaning on one. Though doing that is properly really its own video, the forgetting is not a bug, it is the feature. So, HTTP has no memory by default, and a cookie is just the note you hand back on every request that says, "It's still me." The login side of this, real sessions, tokens, is a whole video on its own as well. But right there is the heart of it. Okay, we send the request. Now the server does its thing, routes it, checks the cookie, maybe hits a database, and sends back a response. And the response has the same shape as the request, basically flipped around. A status line up top, then its own set of headers doing the same kinds of jobs, then a body. Except the first line is not a method anymore, it's the verdict. HTTP 1.1 200 OK. That number 200, that is the status code. It is the machine readable answer too. So how did it go? And the OK sitting next to it, that is just a friendly label for humans. The software really only cares about the number. Now, there are a lot of these codes, but please do not sit and memorize them. Just learn the families. The first digit tells you almost everything. Anything starting with 2, 2 cross cross means it worked. 3 means go somewhere else for this. And 4 means the problem is on the request side. Something about what was asked cannot be served as sent. And a 5 means the server ran into a trouble handling it. That is most of it. 2 is good, 3 is go elsewhere, 4 is the request side, 5 is the server side. Now, let me hit a few specific ones because some of these get misunderstood constantly. I got them wrong for years. Start with the famous one, 404 not found. Everyone has seen it, and most people read it as the site is down. It is not. A 404 means the server is perfectly healthy. It is up, it heard you, it answered. It just could not find that one specific thing you asked for. Healthy server missing page. That is a completely different situation from the site being down. Then, 2 that gets fabbed all the time, and the names really do not help here. 401. It literally says unauthorized on the label, but what it actually means is unauthenticated. I do not know who you are. Please log in. And 403, forbidden, is a different thing entirely. I know exactly who you are, and no, you are not allowed to see this. So, 401 is who are you? 403 is I know who you are, and the answer is no. Same ish looking error, totally different cause. And 500, internal server error. This one means the server's own code hit something it could not handle and just broke. And notice, that is not your internet, that is not your fault. Your request was completely fine. Something on the other side failed. Could be a bug, could be too much load, could be another system they rely on breaking. Either way, not you. So the status code is the verdict, and just carry these two out of here. A 404 is not down, it is I couldn't find that one thing. And a 4 is a problem with the request, and a 5 is the problem on the server. Before the body, there is one response you see constantly, probably 100 times a day and never notice. A redirect. Let us say a page moved. It used to live at slash old, now it is at slash new. You ask for slash old, the server does not have it there anymore. But it does not just error out. It sends back a 300 code, a redirect, plus one header called location that says not here, it is over at slash new. And here is the part people quietly get wrong. The server does not forward you. It does not go fetch the new page on your behalf. It just replies with the new address. And then your browser turns around and sends a brand new request to slash new. So a redirect is not one magic jump. It is two requests. Where is it? It's over there. Okay, give me that. Two round trips. And now you know why a redirected link feels a touch slower. Okay, now the last part of the response. After the status line, after the headers comes the body, the actual result. For a web page, the body is HTML, the page itself as text. But here is the thing that reframed the whole web for me the day it clicked. That first HTML is not the finished page. It is more like a shopping list. The browser reads it top to bottom and goes, okay, I need this style sheet to style it, and these three scripts to run it, and this logo, and eight more images, and a couple of fonts. And for every single one of those, it fires off a whole new HTTP request. Same exact dance. Method, path, headers, a response with a body, again and again and again. So loading one page is almost never one request. It is often dozens, sometimes a couple hundred. Everything we just learned, request response, happening over and over. For every little piece, the page is stitched together from. So, a redirect is just the server handing your browser a new address to go ask at. And one page is not one download, it is a whole pile of these requests, one for each piece. Okay, I have been showing you web pages this whole time. Browser asks, server sends HTML. But here is what is kind of neat. This exact same shape is everywhere. It is not just a web page. It is basically how machines talk to each other. Let me give you my favorite one. You know when you call an AI model through its API, and an API is just the doorway one program uses to talk to another program. Like in your own code, hitting ChatGPT or Claude, that call, it is this. It is a HTTP request, a post because you are sending data, your prompt, a header, authorization carrying your secret API key. That is the credential we talked about, a body in JSON with your prompt inside it. And the answer comes back as a response, stream it to you piece by piece. So that AI API that can feel like magic under the hood. It is the same exact method, headers, body, and status code you just learned. Once you can see the shape, you start seeing it everywhere. Every app, every API, every service is doing this. And one quick honest note, I have been showing you this nice readable text get host in plain letters. That is exactly how the classic version HTTP 1.1 looks. And it is the best way to learn it. The newer versions, HTTP 2 and HTTP 3, just pack the same information into a compressed binary format for speed. So it is not readable text on the wire anymore, but the meaning is identical. Still a method, a path, headers, a status, a body. Same contract, faster packaging. That is why your dev tools still show you all of it, no matter the version. And one last correction, quick but really useful. Remember the path and the query, all the stuff sitting in the URL. HTTP hides all of that in transit. Nobody on the network can read it. Good, but a URL is still a URL. After it arrives, it gets written into your browser history, into server logs, into analytics tools, and it can even leak to other sites through a header called referrer. So even over HTTPS, keep secrets out of URL. A password or a token belongs in a proper credential header like authorization, not baked into the web address itself. Encrypted on the wire is not the same as safe to write down anywhere. So, same contract everywhere. A web page, a phone app, your AI call, the version can change the packaging, it never changes the meaning. Okay, let us pull all the way back and see the whole thing at once. One request, start to finish. You have a tunnel from last video. Through it, your browser sends a request, a method, the verb, what action you want, a path, the thing you want it done to, a stack of headers, the instructions, which site, what format, who you are, and maybe a body, the payload. The server reads all of that, does its work, and sends back a response, a status code, the verdict, some headers, and a body, the result. Request response, that is the entire conversation. And here is the shift I really want to leave you with. Most people picture a HTTP request as basically a URL. You type an address, a page comes back. Let that go. A request is not a URL. It is a little contract, a verb, a target, a stack of instructions, and sometimes a payload. And the exact same address can mean completely different things depending on the contract. Get this, post this with these headers as this user. Those are all different tasks, even to the same address. The URL is just the start of the sentence, the request is the whole sentence. And once that clicks, a huge chunk of the internet stops being mysterious. Loading a page, submitting a form, an app syncing your photos, your code calling an AI model, every one of them is the same little ask and answer happening millions of times a second. You are not looking at magic anymore. You are looking at a very, very simple conversation, repeated at an enormous scale. That is the whole thing. So, we have got the request and we have got the answer. And every one of those headers we breeze past, the cookie, the cache, the auth token, each one opens up its own little world. That is where we are headed next. So, if you want to keep pulling this thread with me, stick around.